Hello, my beloved students. I am here with you, Mr. Abdul Nasser Gaber, and the wonderful team of Studio 12 in Educational Egyptian channel. We are going today, inshallah, to study trig 1, trig part 1, and we will study the directed angle. First of all, we have the angle. What is the angle? If we draw a ray like that, we call it AB, and another one like that, we call it AC. This is the angle. What is the angle? As we know from the previous studying, the angle is the union of the ray AC union the ray AB. Okay, that is the previous studying for the angle. It is the resulted position which resulted from the union of the ray AC and the ray AB. Okay, today inshallah we are going to study the directed angle. What is the directed angle? We just name a ray like that. We call it, as example, OA, and we call it initial side. Okay, and another ray like that, OB, and we call it terminal side, terminal. This angle we call it directed because of directions. We have here the direction. Okay, the direction here expresses the direction of directed angle. This angle measured like that. This direction is called positive direction because it is anti-clockwise direction. When the direction of the angle like that, is it a positive direction, and it is anti-clockwise direction. Anti-clockwise direction. Okay, we have here the directed angle. First of all, we have initial side like that. We have the initial side, we have the terminal side, we have the direction started from initial side to terminal side. Okay, and this direction will be positive because it is anti-clockwise direction. Let us draw again another directed angle. We have this angle OB and another angle and another side OC. This angle will measure like that. We measure it from OB to OC. OB is initial side. Yes, OB is initial side, and OC is a terminal side. And this direction is on clockwise direction. If you have a wise or an hour like that, you have the direction. This direction means on clockwise direction, which is negative. Okay, So we have two directions for the direction angle. First is positive, which is anti-clockwise direction, like that, will be positive, and this direction unclockwise direction and will be negative. Let's go to another angle, which is the standard position. Let's go to the first slide here. This slide. We call this standard position of the directed angle. What is the standard position of the directed angle? When we have like that, we have initial side, which is OX, and terminal side, which is OY. We have this angle, we call it angle in standard position. Yes, we have here 0 degrees, we have here 90 degrees, we have here 180 degrees, and here 270 degrees, and we return again 360 degrees. So when the angle, its vertex is the origin point and its initial side is OX, or the positive direction of x-axis, and its terminal side anywhere, here or there or anywhere, we call it standard position of the triangle. Okay, let's go to the next slide. This part we call it first quadrant, and this side we call it second quadrant. First quadrant include between 0 and 90 degrees. Second quadrant from or between 90 to 180. Third quadrant include between 180 and 270. Fourth quadrant include between 270 and 360. We see that the directed angle is very easy, and the directed angle started with initial side, which is OX, or the positive direction of x-axis, and its diagonal anywhere, may be in the first quadrant, second, third, or fourth quadrant. Okay, let's go to draw a directed angle like that. We have here OX and this is B. This angle, is it positive or negative? Yes, it is positive because it is anti-clockwise direction, like that. Okay, this angle, if it is 60 degrees, okay, then we have another angle which is equivalent to it. This circle equals 360 degrees. Okay, 360 degrees here, when we subtract 360 minus 60 equals 300 degrees. Okay, let's go to another slide here. What is the positive angle? As we said, the positive angle are generated by counterclockwise or anti-clockwise direction rotation. Negative angles are generated by clockwise rotation. Let's talk about how negative angles are labeled on the coordinate graph. Negative angles. We have here, yes, we have here the initial side, which is the positive direction of x-axis, and terminal side here, and this angle equals 45 but in negative, because we go here on clockwise direction, so it is negative 45 degrees. Okay, in this year we study positive direction of the directed angle and negative direction. Last year or the year before, we studied just an angle, no positive or negative. Okay, so let's go to another slide. Angles are often named using the following Greek letters. We used Greek letters as alpha. We call this symbol alpha. We call this symbol beta. We call this symbol theta. Alpha, beta, theta. And sometimes we call it like the original or traditional letters as A, B, and C. Coterminal angles. What is the coterminal angles or equivalent angles? We have here, as you see here, we have an alpha angle, and it's anti-clockwise direction, so it is positive. And we have this angle. Look carefully. Yes, we turn one round and go to the same terminal side. Yes, we have alpha, to the smallest angle, and after that we add a complete round around the origin point and return again to the terminal side. So alpha and beta, which is returned again to the same terminal side, we call it coterminal angles or equivalent angles. And look here, we have alpha, its position directed angle, started from x-axis, go the terminal side, which is here, and beta, which is started from the positive direction of x-axis and goes to the same terminal side. So alpha is equivalent to beta, or we can say there are two coterminal angles. They are coterminal angles, alpha and beta. Let's go to coterminal angles also. We have here 60. The question says that they have the same initial and terminal side. Determine two coterminal angles or two equivalent angles, one positive and one negative for 60 degrees. Look here, we have 60 degrees angle, which is in position, standard position angle, okay, because its initial side is OX and this side is a terminal side. What we do to find two angles, they are positive and negative and coterminal to 60, we do what? 60, add to it 360, so the answer will be 420 degrees. Then the angle of measure 420 degrees is equivalent to the 60 degrees because it turned another round or complete round and returned back to the terminal side. This 60, we add it to negative 360. Negative means we turn opposite side or we turn on clockwise direction, so it is negative. 60 plus negative 360 equals negative 300 degrees. Give two coterminal angles for 30. Let's look here. If we have here an angle of measure 30 degrees like that, and we would like to find two coterminal angles or two equivalent angles for 30. First, we add 30 plus 360 will be 390 degrees. So the angle 390 degrees is equivalent to the angle 30 or coterminal to the angle 30. And if we find another coterminal, if we want to find another coterminal angle, we add 30 plus negative 360. The answer will be negative 330 degrees. So the angle negative 330 degrees is a coterminal angle, but it's a negative angle. It's negative coterminal angle or negative equivalent angle to the angle 30. Let's go the start of the slide. Yes, as we did, 30 plus 360 equals 390 degrees, and so 390 degrees will be equivalent angle, but it's positive. The positive equivalent angle or the positive coterminal angle for 30 degrees. And this one, we add 30 to negative 360, which is negative 330 degrees, which is another negative coterminal or equivalent to the angle 30. Give coterminal angle, one positive and one is negative, to 230. If we add 230 here and 360 here, we'll find the answer will be 590 degrees, which is the sum of 230 plus 360, because 360 means one turn, one complete round, and 230 here plus negative 360, which is completely round but on clockwise direction, equals negative 130 degrees. So negative 130 degrees, it is the equivalent angle, but it's negative for 230, and 590, it is the equivalent angle to 230. Let's go the next slide. Give a coterminal angle, one positive and one negative. Negative 20 plus 360 equals 340 degrees, and negative 20 plus negative 360 equals negative 360 degrees. Give a coterminal angle, one positive and one negative, for 460. 460 plus 360 will be 820 degrees, but it is not very good because we want simplest form angle. And if we add 460 plus negative 360 will be find the smallest positive angle here, which is equivalent to 460. We call it the smallest positive angle, which is equivalent or coterminal to 460 degrees. Look here, we have 100. If we add it to negative 360, the answer will be negative 260 degrees. So the smallest negative angle, which is equivalent to 100 or 460, equals negative 260 degrees. What is the complementary angles? We have complementary angles and supplementary angles. Let's go with complementary angles. There are the two angles that their sum equals 90 degrees. Their sum equals 90 degrees. We have here a question the question will said, find the complement of each angles, 40 degrees and 120 degrees. We will find 40 plus some angle x equal 90, which is x equal 50 degrees. So 50 degrees here, 50 degrees here is the complement angle for 40, because their sum equals 90 degrees. But 120 has no complement. Why? What number, if it is added to 120, equals 90? No number. No number can add it to 120, and the result will be 90 degrees. So it has no complement angles. Find the supplement angle of 40 and 120. We know that supplementary angles are the two angles that their sum equal 180 degrees. So we have here 40 degrees. We want to find another angle and adding it to 40, the answer will be, or the result will be 140. And look for another angle. If it is added to 120, the answer will be 120. So the two angles will be supplementary. Supplementary angles mean that the sum of the two angles equal 180. Yes, we have here 40 plus x. 40 plus x equal 180. So x equal 140 degrees. And 120 plus x equal 180. So x equal 60 degrees. Okay. Coterminal angles, angles which added to plus or minus 360. The complementary angles means 90 angle or 92 angles. Supplementary angle mean 182 angles. Let's go to a paper now. Yes. If we have 30-degree angle here, and we want to find some angles which are equivalent to it, we can find the positive first, plus 360. The answer will be 390 degrees. And if we want to add 2 rounds to it, will be 720 degrees. The answer will be 750 degrees, and so on. So 30 plus any number of rounds, which we call it n, multiplied by 360, the answer will be an angle which is equivalent angle to 30 degrees angle. So if we want to find the positive angles which is equivalent to 30 degrees, we add to 360 720, or 3 times 360, or 4 times 360, and so on. And if you want the negative angles, we can add minus here. We can add 30 to negative 360, or 30 to negative 720, or 30 to minus any number here. The n, we can call it n belongs to z, which is z will be 0, 1, 2, and so on, or negative 1, negative 2, and so on. So z, which is integer number, we can put 0 instead of n. We can put 1 or 2 or -1 or -2 and so on to find equivalent angles. My dear students, positive and negative angles is very important for studying physics, graphs, and many things in different science. So we'll go to another slide here. Look here. What is the radial measure? We used to use degrees, minutes, and seconds here. 1 radian means what? It is another method to measure angles. Look here. We have here the angle theta, and this is r, which is radius, and this is radius 2, and we have here the arc of the circle which subtends theta. Okay, we have theta here. Yes, we have S here. S is the length of the arc. Okay, when S equal R, then theta here will be 1 rad. Okay, let's see what is the C? C is the circumference of the circle, equals 2 pi r. When we divide the two sides by 2 pi here, if we divide C and 2 pi r, C means circumference of circle, which is mean perimeter, or the length of the whole circle here. The whole circle is C. We find C by 2 pi r. Okay, if we divide the two sides by 2 pi, which is a complete round here, it is a complete round but in red. If we divide the two sides by 2 pi, we will find that r here, the remainder r here, equals C over 2 pi. So 1 revolution is equal to 2 pi. Okay, let's explain here what is the new system of measuring, which we call it radian measure. We used to use the protractor here. Protractor here start from there, 0. Yes, here is 0. Yes, here is 0, 10, 20, 30, and so on. And if we draw a line like that, then we will draw 180 degrees, starting from 0 to 180. So semicircle or half circle, its measure equals 180 degrees. But if we start drawing from there, will be negative 180 degrees. Here will be positive 180 degrees. And here the 0, 1 degree, second, third, and 10, 20, and so on. Like this. We have here the measure starting from 0, 1, 2, 3, 4, which is very small. We call it degree. So we used to say 1 degree. It is a unit for measuring the angles. Okay, what is 1 degree? 1 degree, small part here, and mathematicians divide it into 60 equal parts. We call them 60 minutes, and each minute we divide it into 60 equal parts. We call it 60 seconds. So 1 degree equal 60 minutes, and 1 minute equals 60 seconds. Okay, this is a degree measure. We call it degree measure. Degree measure. But we have another system of measuring for the first secondary schools and first secondary students. What is the measuring? We have here a semicircle like that, and if we want to complete the circle, we put the protractor here like that and complete the circle. So we have a complete circle here. The measure of the complete circle equal 360 degrees with the measuring system, 4 degrees. But if you want to use another system of measuring, we call it radian measure. We have here the radius here equal another radius here, and when this part or this arc equals r also, all of them equals r, all of them are equal in length, this is r, this is r, and this is r, we call this arc L or S. Yes, Fs equal L equal r. Then this angle we call it theta in rad. Theta here equal 1 rad. Okay, so we have another method to measure angles which is rad. This is theta rad or 1 rad, okay, and 2 rad, 3 rad, 4, 5, and 6. This part is about 28. We know that pi approximately equal 3.14, which is half circle but in radian measure, and 2 pi will be approximately 6.28 rad. So half circle equals pi in rad, the circle equal 2 pi in rad, which is about 6.28 by using the unit of radian, 1 unit. Okay, let's go to another slide here. We have 2 pi, as we said here, 2 pi equal or equivalent in degree measure 360, and 1 pi radian equal 180, and pi over 2 equivalent to 90 degrees. And we know that S, which is circumference of circle or the length of the circle, equals 2 pi r. Okay, let's go here to the radian measure for the circle. The circle divided into 4 quadrants, as you see now here. We have here the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. We have the first, which is included between 0 and 90. 90 here, we call it pi over 2, because pi equivalent to or equal 180. So half pi or pi over 2 equals 90. Here pi, which equal in degrees 180, and here 3 pi over 2, which is equal 270, and return again to 2 pi or 360 degrees. Let's add more. In the middle here, yes, in the middle here we have pi over 4, Yes, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. We add in the middle here pi over 4, which is 45, 3 pi over 4, and 5 pi over 4, and 7 pi over 4. Let's talk about more common angles. Let's take a look to more common angles that are found in the unit circle. We will explain what is the unit circle here. If we have a circle and we have x-axis here and y-axis, this is the origin point O, x-axis, x dash, y and y dash. Okay, this is the origin point. If the length of the radius of this circle equals 1 unit, this is equal 1, 1, 1. Since each radius here equals 1 unit, 1 unit, 1 unit, 1 unit, 1 unit, we can say 1 centimeter, 1 meter, 1 kilometer, as we wish. If we have each radius equal 1, so we will call this circle is a unit circle because its radius equals 1 here. Okay, we know that here is 0 degree and here 90 degrees, which is equivalent to pi over 2 as radian. Here 180 degrees or pi. Here 270 degrees or 3 pi over 2. And return again to the beginning part or beginning side, which is 360 degrees or 0 degrees. So we have here the unit circle, which is very important to you to study. We have the origin point is the center of the circle, and we have each radius here, because radii are equal in length, each radius equal the unity, or equal 1 centimeter, 1 meter, 1 kilometer, the length unit. This is a circle unit or unit circle. This is the first quadrant, second quadrant, third quadrant, fourth quadrant. We have here first quadrant include between 0 and 90, second include between 90 and 180, third include between 180 and 270, fourth include between 270 and 360. If we have angles and we want to find out where these angles lie in the quadrants, as if we have angle as 50 degrees, 50 degrees here, where it lies in the first or second or third or fourth quadrants. We know that 50 is included between the OX with the initial side and OY. We have here 50 degrees. The terminal side lies on what? Lies on the first quadrant, because we know that the first quadrant includes between 0 and 90 degrees. So 50 lies in the first quadrant, but 130 degrees, 130 will lie in the second quadrant. Why? Because the terminal side of this angle lie in the second quadrant, which is included between 90 degrees and 180 degrees. So 130 here lies in the second quadrant. And if we draw another angle like that. Here, this angle, its terminal side here, lies in third quadrant. So it may be 190 or 220. 220 here lies in third quadrant, because third quadrant include between 180 and 270 degrees. And if we have the terminal side here, the angle may be equals 300 degrees. 300 degrees lies in the fourth quadrant because it's included between 270 and 360. If we have the angle 330 degrees, it will be a quadrantal angle. Let's talk about the angles again. We have angles lies in the first or second or third or fourth quadrant, but we have another angles which we call them quadrant angles. What are the quadrant angles? Let's see here. If we have x-axis and y-axis like that, we have here x-axis and y-axis. That's x dash, which is negative, y, and y dash. Okay, this is the first quadrant, second quadrant, third quadrant, and fourth quadrant. If we have an angle, its measure equals 0. The angle of 0, we have its initial side and its terminal side coincident here, so it's a quadrantal angle because it lies on the x-axis. If we have 90 degrees, we have its initial side here and terminal side here, so it's a quadrantal angle because a 90, the terminal side, its terminal side lies completely on y-axis. 180 degrees, its terminal side lies here and its measure will be 180 degrees. So 180 is a quadrantal angle because the terminal side of it lies completely on x-axis. We have here also 270 degrees angle. 270, its coterminal angle side, its coterminal side lies on y-axis, OY dash, exactly. And if we have 360 degrees, which is complete round anticlockwise, this angle also is a quadrantal angle because its terminal side lies on x-axis. So any angle, its coterminal angle or coterminal side lies on x-axis or y-axis, we call it quadrantal angle. We call it quadrantal angle. So let's go again to the next slide. Here we have angles here. We have angles here. 0 angle, 90, 180, 270, 360. We have here pi over 6, which is 30. And 5 pi over 6 here, 7 pi over 6 rad, 11 pi over 6 rad, and pi over 3 rad, 2 pi over 3 rad, 4 pi over 3 rad, and 5 pi over 3 rad. So we have a conclusion here. This is the quadrantal 1 include between 0 and pi over 2, which is 0 and 90. Second quadrant include between 90 and 180, which is pi over 2 and pi. The third quadrant include between 180 and 270, which is pi and 3 pi over 2. And the fourth quadrant include between 270 and 360, or 3 pi over 2 and 2 pi. As a homework for you, my dear students, determine the quadrant of the terminal side of each given angle. Write these questions: pi over 3, 7 pi over 12, negative 2 pi over 3, 371 degrees, and we can find it in degrees if we put this pi 180. Instead pi, put 180 over 3. It will give you the degrees measure. 7 times 180 over 12, and negative 2 times 180 here over 3, and try to find out what quadrant will be there. Okay, my dear students, I am so happy to being with you today, and thank you for watching. Wait us inshallah next week at the same time, 10:30. Thank you. Wonderful teamwork in channel Egyptian Channel for Education. Thank you, our students. Thank you, and until we meet again, goodbye and good luck.